Monteverde is a 30-point Windows machine on HackTheBox that involves some LDAP and SMB enumeration to get the user flag. For root, we exploit Azure AD Connect's way of storing a password for the account that synchronizes on-premise AD accounts with Azure AD. The initial port scan shows that we are dealing with a domain controller. We start by using WinLab search to enumerate the users on the domain. To proceed, we extract a clean username list from the WinLab search output. Using Metasploit, we brute force username-password combinations on SMB. In this case, using the username as the password is sufficient and we get a hit for the user as a batch jobs. SMB map shows that there are several SMB shares. Especially the user's share looks interesting, so we connect to it and list its contents recursively. This shows that in mHope's hope folder we have a file called azure.xml. We download the file and can see the user's cleartext password in it. Now we can use this password to connect to the box via WinRM, which allows us to read the user flag. The first thing we want to do on Windows boxes is to run a priver script to find low-hanging fruits and get some situational awareness. In this case, I'm using the awesome priver script by Itman. We notice that MS SQL Server services are installed, and in the non-default applications we can see that Azure AD Connect is installed as well. The netstat output confirms that MS SQL Server is running on localhost. While doing some research on Azure AD Connect vulnerabilities, we find an excellent blog post by Adam Chester, which explains that Azure AD Connect is used to integrate existing AD environments into Azure AD. One feature is password hash synchronization, which synchronizes user accounts and passwords with Azure AD. By default, it uses a user starting with MSOL_ to do the synchronization. A local database is used to store information about this user, and it turns out that this database also stores its encrypted password. Luckily, everything we need to decrypt this password is either in a database as well or stored on the machine, which means that we are able to decrypt it. Adam provides a script in his post that performs all the required steps. The only thing we have to change is the connection string, as we're having a MS SQL server here that stores the data. After modifying the connection string, we copy-paste the complete script into our WinRM shell and get the cleartext password of the administrator. I expected the MSOL_ password here, but it seems it was somehow configured to use the administrator's account instead. Now we can use WinRM to connect as administrator and read the root flag.